Welcome to the second video of this course bundle in which we are studying the different types of isomerism in case of organic compounds. So now we will be moving into the detailed study of all the different types of isomerisms, and we are now starting with the all 6 types of structural isomerisms. In this very video, I am covering only 2 types of structural isomerisms. Number 1, the chain isomerism or the skeletal isomerism, and number 2, the position isomerism. Now let us move into it. I'm just sharing my screen with you. Okay, so let us start with it. So the number 1 type of structural isomerism is skeletal or chain isomerism. Skeletal or chain isomerism. Now, why do we call it as skeletal isomerism? This is because the carbon chain in organic compounds is the center of the molecule. Okay, so it is the main part of the organic molecule. So it is known as the skeletal isomerism. So it forms the skeleton of the organic molecule. So in this case, in this type of isomerism, 2 or more molecules will have the same molecular formula, but they will have different length of carbon chain. Same molecular formula and different length of carbon chain. All right, now let us move into the examples. For example, suppose we have molecular formula C4H10. Okay, now this is a 4-carbon compound. The 4 carbons can be in the straight chain. The 4 carbons can be in the form of branching also. Now let us see what are the possibilities. So it is CH3, CH2, CH2, CH3. Now we have already discussed the nomenclature of the organic compound. So very easily you can write the name of this very compound. It is N-butane. All right. Now there are 4 carbons in one chain. 4 carbons in one chain. Now let us try to write it in another form. CH3, CH, CH3, CH3. Okay. Now this is isobutane, or it is 2-methyl. If we write the IUPAC name, it is 2-methyl propane. All right. Now in this case, there are 3 carbons in the main chain. 3 carbons in the chain, and this is acting as the substituent. So this is what we call as the chain isomerism or skeletal isomerism. The length of the carbon chain will be different, although if you count the number of carbon atoms and the number of hydrogen atoms in these 2 molecules, in this molecule and this molecule, it is going to be C4H10. Now let us take one more example. C5H12. Now it is a 5-carbon compound. Let us take all the carbons in one chain. So all the 5 carbons in one chain. Now let us complete the valencies. CH2, 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 CH3. Now it is N-pentane. Now start writing the names of the compounds yourself, because we have already discussed the nomenclature. Okay. Now it can be another form. We have already done these forms of pentane. We have done N-pentane, isopentane, and neopentane. And why we write these prefixes N, iso, and neo, we have already discussed. I hope you have revised it. Okay. And this is isopentane. Write the IUPAC name of this compound yourself. All right. Now here we have 4 carbons in the chain. Here we have 5 carbons in the chain. Now let us write the formula for neopentane. In this case, in neopentane, how many carbons are there in the main chain? 3 carbons. So this is what we call as the skeletal or the chain isomerism, in which the molecular formula of different compounds will be the same, but they will be differing in the length of the carbon chain. All right. Now, if you count the number of carbons and hydrogen in these three, they are going to be C5H12. Now, let us take one more example. So suppose the common molecular formula for a compound is CH3, CH2, CH2, CH2OH. It is butane 1-ol. Okay. Now we can write it as butane 1-ol can also be written in the form of isobutyl alcohol. Now you should know what is isobutyl alcohol, because I have already told you how to write isobutyl group. So this is isobutyl alcohol, or the IUPAC name is going to be 1, 2, 3. At the second position, we have methyl group, 2-methyl propane 1-ol. Another form can be this one. Now here it will be 2-methyl propane 2-ol. Okay. Now in this case, the molecular formula is C4H9OH. C4H9OH for all the three. Okay. So now again here, the carbon length is different. Although all are alcohols, they have same molecular formula. The functional group is same. Everything is same, but the length of carbon chain is different. Okay, then let us move to the second type, which we are going to discuss here in this video. It is position isomerism. Position isomerism. Now here in this case, the molecule will be having the two molecules or three molecules which are showing position isomerism. They will be having the same molecular formula. They will be having the same functional group, but they will be differing in the position of the functional group. Okay, so it can be a functional group, it can be a carbon-carbon multiple bond, or it can be also a substituent. So molecular formula same molecular formula, same functional group, but the molecules show different positions of functional group, or carbon-carbon multiple bond, or substituent. So write this complete definition or the complete statement for the position isomerism. The molecules having same molecular formula, same functional group, and all this. You can complete it now. Okay. So let us take the example. For example, if we have CH3, CH2, CH2OH, you will be writing the IUPAC name for this yourself. Okay. Then CH3, CH3OH. See, the length of carbon chain is same in both the cases. 3 carbon chain, 3 carbon chain. Now the position of the functional group is different. Functional group is same, but the position of the functional group is different. So this is, I'm telling you the name, this is propane 1-ol, this is propane 2-ol. Then we can take one more example. Suppose we have CH3, CH2C, triple bond C, CH3. Then we have one molecule which is triple bond CH triple bond C, CH2, CH2, CH3. Now in this case, the multiple bond is having different positions. Molecular formula is same. The functional group or carbon-carbon multiple bond, both are having triple bond. Everything is same, length of carbon chain is same, but the position of the multiple bond is different. Okay, so 1, 2, 3, 4, 5. Here will be 1, 2, 3, 4, 5. So here the triple bond is at the second position. Here triple bond is at the first position. So this is pent 2 ine. This is pent 1 ine. Okay, so this is the positional or position isomerism. Now, when we are talking about benzene ring, it shows position isomerism. It is very common in case of benzene ring. I'm clearing my screen here, and let us now move into the examples from benzene ring. If we have disubstituted benzene ring, disubstituted benzene ring. Suppose on benzene ring we have OH group and Cl. So this is orthochlorophenol. Orthochlorophenol. Oh, I'm so sorry, I'm just erasing it. You can draw the meta isomer, and then you can draw the para isomer. So it is meta chlorophenol. Then we have para chlorophenol. Now the carbon chain is same, 6-membered ring is there, benzene is there. Okay, the molecular formula is same for all these 3 compounds. The functional groups are same, but the only difference is in the position of the functional groups. Position isomerism. So these are the 3 examples of position isomerism, where the molecules have same molecular formula, same functional groups, everything is same, just the position of the functional groups is different. Hope you have understood what is skeletal or chain isomerism. Why we call it as skeletal isomerism? Because the carbon chain is the skeleton of an organic compound. Okay, then we have discussed the position isomerism. Now discuss this in the comment section below, what you have learned from this video. Okay, and I will see you in the next video.